No matter how complex the equation of the plane curve is, the procedure in the solution lies the same. Check how we solve more complex plane curves here in differential calculus. Like how we solved the previous problems in looking for the tangent and normal lines of plane curves, we followed a specific algorithm, which can be simplified in 3 short steps. First is to look for the slope of the equation about the point in consideration. Second is to plug the solved slope and the coordinates of the points into the point-slope formula to determine the equation of the tangent line. And last, interchange the coefficients of x and y and take the opposite sign between them to have the equation for the normal line. Let's look for the equations of the tangent and normal lines for the seesaw with the equation y squared is equal to x cubed upon 2a minus x. We use the point at a. With the equation, start by placing d all over dx to each term as we are to figure out the slope. The left term is easy to differentiate, but with the variable x into both the numerator and denominator of the right term, we need to employ the quotient rule. So we get 2y prime from the left, and the right side has the square of the denominator, 2a minus x. The numerator considers the lower term times the derivative of the upper term x cubed, minus the upper term multiplied by the derivative of the lower term. With the outcome, we distribute d upon dx to the two terms. Then, we get the following equation. dx all over dx is 1, and d of 2a with respect to dx is 0. So we have 2y prime is equal to the quantity of 2a minus x multiplied by 3x squared minus x cubed all upon the square of 2a minus x. Distribute 3x squared to 2a and x. So we get 2y prime is equal to 6a x squared minus 3x cubed minus x cubed all upon the square of 2a minus x, where we can collect the terms with x cubed. Again, if we reduce the coefficients, we get y prime is equal to 3ax squared minus x cubed upon y multiplied by the square of 2a minus x. And this is the equation of the slope m. Using the point considered at AA, the variables in the slope equation can be taken as a to be simplified as m is equal to 3a times a squared minus a cubed all upon a times the square of 2a minus a, which we can collect together and have the numerator cancelled with the denominator, leaving m equal to 2. This is at point AA. Now to find for the tangent line's equation, we plug the slope and the coordinates in the point-slope formula to have y minus a is equal to 2x minus 2a. Arrange the terms by separating the variables from the constants to get 2x minus y is equal to a. With the normal line, we flip coefficients so the 2 with x will be moved as 2y, and y will turn to x, or that is x plus 2y. For the constant, to complete the normal line equation, plug the coordinates AA into the binomial, which is a plus 2a, and that is 3a. So our normal line equation is x plus 2y is equal to 3a. The second example involves a trisectrix with the equation y squared is equal to x squared multiplied by the quantity 3a minus x and all upon a plus x. And the point under consideration is at point AA. Start with integrating d all over dx into both sides of the equation. And take note that the right side of the equation has multiple rules where we can start with the quotient rule. Hence, the equation turns as 2y prime equal to the lower term a plus x multiplied by the derivative of the upper term x squared times the quantity of 3 times a minus x minus the upper term times the derivative of a plus x. In the numerator, note that there is a term where we should also use product rule. We take the first term multiplied by the derivative of the second term plus the second term times the derivative of the first term. Simplify the derivative of 3a as 0 and the derivative of x as 1. Also, the derivative of a is taken as 0. The last term with the derivative is x squared, which can be taken as 2 times x times dx all over dx, also taken as 1. So we get a rather long simplification, but then some terms can be collected to get a plus x times 6ax minus 3x squared minus 3ax squared plus x cubed all upon 2y times the square of a plus x. Then take out the parentheses by expanding the binomials. And note that the negative 3ax squared and 6ax squared cancel out to have a shorter equation of y prime is equal to 6a squared x minus 2x cubed all upon 2y times the square of a plus x. Now let's try to simplify it by extracting out 2x from the numerator, and then plug the coordinates of the point where we cancel out 2a. Then cancel a squared again to end with 2/4 or 1/2. Now we can solve for the equation of the tangent line by plugging m and AA into the point slope formula, which would be y minus a is equal to half of x minus a. Cross multiply 2 to the other end to have 2 times y minus a is equal to x minus a. Distribute 2 to the binomial and then rearrange the terms to have x minus 2y is equal to negative a. The normal line at the same coordinates will be the negative reciprocal of the coefficients like 2x plus y, then substitute the coordinates AA into the expression to have 2a plus a or 3a. So the normal line equation is 2x plus y is 3a. How about the volume with the equation x cubed minus y cubed is equal to 3axy? Using the point of coordinates 3/2 a for both x and y. Find the slope by inserting d all over dx to each term. Take note again that although a is a constant, xy would require product rule. 3x squared is the derivative of x cubed. 3y squared dy all over dx is the derivative of y cubed. The right side of the equation has 3a extracted out, then the derivative of xy is taken as x times dy all over dx plus y times dx all over dx. Again, dx over dx is 1, and dy all over dx is y prime. So the equation is simplified as 3x squared plus 3y squared y prime is equal to 3a times the quantity of x y prime plus y. If we distribute 3a into the binomial to take away the parentheses, we get 3x squared plus 3y squared y prime is equal to 3ax y prime plus 3ay, where we can simplify everything by taking off the constant 3. Move all the terms with y prime to the left and all others move to the right. Extract y prime and have the binomial with it as the denominator of the right side binomial. With the point under consideration plugged into the variables x and y of the slope formula, say that we use decimal form to simplify bars, we can simplify the slope equation into negative 0.75a squared all upon 0.75a squared, which is simplified further as negative 1. With the slope known and plugged into the point slope formula, we create an equation which can be simplified as y minus 3 halves of a is equal to negative x plus 3 halves of a. Rearrange terms to collect those with variables to the left and the constants to the right, having the tangent line equation as x plus y is equal to 3a. Then for the normal line equation, we flip coefficients and take the sign reversal, showing x minus y. Then plug the coordinates into the expression to have 0. So the normal line equation is x minus y is 0.